Hi, my name is Angelina Dominguez, and I teach AP Computer Science Principles at Veterans Tribute Career and Technical Academy in Las Vegas, Nevada. Let's find out what we're learning today. So we'll be looking at how to protect our systems using a couple different methods to keep our data safe, as well as how our computing resources can be misused. Let's jump in. In order to access secure systems and networks, a user should be authenticated by the computer they're using. Authentication measures protect devices and information from unauthorized access. Examples of these include strong passwords or something called multi-factor authentication. Let's talk about passwords first. The easier a password is to guess, the less secure it is. So it makes sense that it's important for users to create passwords that are considered strong. These passwords are usually a certain length, like 8 or 10 or more characters. They normally contain symbols and numbers in addition to upper and lowercase letters. And they aren't made of easy to guess words or phrases. Generic words like password or just numbers or birthdays or names of like your pets or your siblings, those would be considered weak passwords because someone could guess them just from knowing a little bit about you. Some network systems or websites employ multi-factor authentication. This type of authentication is based off of either what you know, like a password or answers to security questions, what you are, biometric data, like an eye scan, a palm print, thumbprint, or what you have. This would be something like a key card that you swipe to enter a door. If a system requires a user to enter a password, what you know, and also one of the other two things like swipe a card or scan your palm print, then the system requires a multi-factor authentication in order for you to gain access. Another example would be when you log into a computer and you may need to type a password, and then the computer will ask you to verify your identity by clicking on a notification that it sends to your phone. Or it may require you to scan your fingerprint in a reader. That second step with what you have or with what you are that only you would have with you ensures that someone who is not you didn't just get your password and then is trying to pose as you. More factors can be added to the process, and each step adds an extra layer of security. Unfortunately, sometimes computers and systems can be compromised in a way that allows bad actors to bypass these authentication methods. Viruses can allow unauthorized access by modifying the operating system to accept any user without authentication. Viruses are malicious programs that can copy themselves and gain access to systems that they're not supposed to be allowed in. Malware can sometimes act the same way, and it usually damages a system or takes partial control over the system's operation. Both types of software can infiltrate a system by posing as legitimate programs or by attaching themselves to a legitimate program like in an email attachment. Running virus scans regularly can help to prevent malicious code from doing this. Keeping the operating system and other software up to date can also fix errors that would allow a virus or malware to compromise a system. Now, once a user has gained legitimate access to a system, it can be important to ensure that all data sent from the system remains uncompromised as well. If someone were to intercept the data that was sent over the network, they would be able to use it maliciously if they could read it easily. Encryption takes care of that, though. Encryption is a process of encoding data to prevent unauthorized access. When the data is decoded, it's called decryption. You can think of encryption as a coded message that someone with the key can decipher. There are two types of encryption, symmetric and asymmetric. Symmetric encryption involves one key that the sender and receiver both know, and that key allows a message to be both encrypted and decrypted. An example of this encryption is a Caesar cipher, in which a message is shifted by a certain number of letters. And again, both the sender and receiver know the key, or in this case, the number of letters the message is going to shift. Let's look at an example. Here we see an example of a Caesar cipher. So if you want, pause the video and go ahead and give it a try. See if you can crack this encrypted message. Welcome back. Did you get hello with a key of 5? If so, well done. This 5-letter shift encrypts the word hello to be MJQQT. At most, this would take 26 guesses to crack this encryption and find the key and the secret message. So it's not a very secure method, especially nowadays with computers. And also, especially if you take into account the fact that both the sender and the receiver would have to meet ahead of time in order to decide on what the secret key is going to be. Now, if we're trying to encrypt data on a computer that aren't sitting right next to each other, how do two computers meet ahead of time to do that? Well, that's where asymmetric encryption comes in handy. In asymmetric encryption, also known as public key encryption, two keys are used: a public key for encrypting that anyone has access to, and a private key for decrypting. In public key encryption, a sender can encrypt a message or data without having the receiver's private key, but the receiver's private key is required in order to decrypt the data. With a symmetrically encrypted message, if someone were to intercept the data and they knew what type of encryption was used, they could crack the data easily even if they didn't know the key. However, with public key encryption, even if the data is intercepted, it will remain encrypted because a second private key is needed. So even if they knew that public key encryption was a type of encryption that was used, it would be next to impossible to crack this encryption because they don't have that second private key. Really understanding the intricacies of how public key encryption works involves some complicated math that we won't get into and we really don't need to worry about. What we should understand is the basics of how the encryption works and how two people or computers could agree on this secret key without ever meeting ahead of time. So we're going to try and understand it with food, all right? Stay with me here. So let's say you and your friend are going to make smoothies. First, you agree ahead of time on the type of fruit you both are going to start with and you're both going to use. Let's just say it's bananas. Anyone eavesdropping can know this information and know that you're both making smoothies with a banana. That's your public key. Next, you both choose a random different private fruit to mix into your public banana smoothie in order to disguise your private fruit. Say you choose strawberry and your friend chooses blueberry. Neither of you tells the other what private fruit you chose. You mix your smoothies, yours with banana and strawberry, hers with banana and blueberries. You keep your private fruit and send your mixture to your friend. She keeps her private fruit and sends her mixture to you. You now have their banana blueberry smoothie, and she has your banana strawberry smoothie. Notice the eavesdropper can see both of your mixtures being sent back and forth, but they can't unmix them to see what each of you added to the banana. Now the heart of the trick. You and your friend add in your private fruit to the other person's mixed smoothie. You mix in strawberry to the banana blueberry smoothie, giving you banana blueberry strawberry. and they mix in blueberries to their banana strawberry smoothie, giving them banana blueberry strawberry. So notice how you both arrived at a shared secret smoothie. And anyone who intercepts the smoothies being sent between you are unable to determine the exact fruit needed. They would need to know one of your private fruits to do so. Now, like I said, to do this with numbers, we need a numerical procedure that involves something called modular arithmetic, some exponential multiplication and division and prime numbers, and it's too much. It gets pretty complicated. So I'm pretty glad we don't have to know the specifics. Now, in order to ensure that the right parties own the correct encryption keys, digital certificates are issued to validate ownership of those keys. These certificates are linked to the places where data is stored or transmitted, like a website, and can typically be viewed in a web browser. Now, if a web browser detects that a certificate is out of date or invalid, you'll get a warning that the website might not be safe to visit. That's it for today. We've reached the end. Let's let's go over what we learned. So we looked at how to protect our systems using a couple different methods such as strong passwords, multi-factor authentication, that's a mouthful, different types of encryption, as well as how things like malware and viruses can be used to damage our systems. So that's it. See you next time.